Hi there, everyone. Thanks so much for joining. You've tuned into the DigitalOcean Tech Talk in our Solutions series. My name is Darian. I'm a senior solutions engineer here at DigitalOcean. I focus on the Americas and EMEA markets. I'm happy to be your moderator today and one of the speakers for today's session. Very excited to have everybody joining us today. I'm going to go ahead and present this. That's strange. Sorry, one moment here. Click the wrong button. Great. So in this series, we're going to bring you insights from the cloud industry, like the latest developer technology trends and topics. And also we're going to feature some really cool organizations showcasing exciting real-time use cases on cloud. And speaking of which, today we're going to be talking to the Data Incubator, which is an EdTech provider. We wanted to talk to them today. They have some really interesting stuff going on. I'll introduce them. First of all, we have Michael Lee. He's the founder and president of the Data Incubator. It's a data science and placement firm. Michael bootstrapped the company and guided it towards a successful sale to the Pragmatic Institute. And previously worked at Google, Anderson Horowitz, JP Morgan, D.E. Shaw. He's a regular contributor to the Wall Street Journal, TechCrunch, Wired, Fast Company, Harvard Business Review, etc. Everybody wants a piece of this guy. Fortunately, we got an hour of his time today. Our second speaker is Robert. As you can see in the other webcam here, Robert is a data scientist in residence at the Data Incubator and has been a key contributor to a variety of open source software development and data science projects. And then finally, over on the very end there, it's yours truly, Darian Wilkin. I've been with DigitalOcean since May of 2016. I help DigitalOcean customers migrate their workloads from other cloud providers, build applications. I give them suggestions on best practices and standards. And I also contribute to our technical documentation and refining tutorials as well. You can find some of my work on the community site. Thanks so much for joining us, Michael and Rob. I wanted to get through a couple, sorry, oh, sorry, go ahead.
I was just saying thank you for having us.
Yeah, appreciate it. I wanted to get through a couple of housekeeping things. I apologize. First of all, through the session, you guys will have access to a chat window on the GoToWebinar portal. Please feel free to use that and share your questions with us. My colleagues Piyush and Cynthia will be moderating the chat window, and they're going to answer any questions at the same, answer any of those questions in the last 15 minutes of the meeting when we have a Q&A. During the session, if your audio stops or stutters, please just restart the GoToWebinar portal. You'll be able to get back in, and that should fix the problems. And then finally, obviously, given this current situation of the world that I don't think I need to explain to anyone, we're all working from home today. So we normally would like to, have everybody at the same place in person, but we're all working from our home offices. So bear with us if we have any connectivity issues. We'll get the person right back online as soon as we can. And then I wanted to move on to talk about our topic a little bit. So the subject today is scaling a school, bringing data science curriculum to 20,000 students in the cloud. And that's exactly what the Data Incubator has done. So we're going to first get an overview of the Data Incubator, what they do, their kind of journey to this point. We're going to talk about some challenges that they've faced. We're going to talk about the tech that they utilize on the back end and the specific stack. And then we're going to talk a little bit about why they chose DigitalOcean, the services that DigitalOcean provides that help them perform this scaling magic. And then we are going to have a question and answer session at the end. So without further ado, I'm going to go ahead and hand it over to you, Michael. Thanks so much.
Thank you so much for having me. And it's a pleasure to be here. So I'm going to start things off by just giving a brief overview of the Data Incubator. So we're probably most famous for our fellowship, where every quarter we get over 2,000 applicants. They are people with PhDs and master's degrees from many of the leading universities in the US and all over the world. And they come and apply for the program. It's a very selective process. We only take the top 2%. And then we work with them through this free program, which is now online because of COVID. And over this course of 8 weeks, we teach them all sorts of things about data science, big data, how to clean data, how to do machine learning. And at the end of it, how we take them and we help them get jobs with a lot of our hiring partners. That's a sort of an exciting program. It's our flagship program, and that grew really, really quickly. We're then probably, the second thing we're probably famous for is corporate training. Because a lot of our partners would come over and say, hey, it's great that we hire 2, 3, 4 folks from you a quarter, but that doesn't really move the needle for us. What we really need is to take our hundreds of actuaries or thousands of BI analysts and get them all trained up on data science. So we took out a lot of our curriculum, put it into bite-sized chunks, and worked with companies to deploy that either, well, previously on-site and now virtually, and to do these trainings. And we also offer these trainings online in the self-serve model as well. So if you just want to take a class from us, you can do that. You can find out more at the dataincubator.com. And then finally, I think the thing that sort of sets us apart is really this idea of skills development. I've been to a lot of trainings where people sort of show up and they have a nice PowerPoint slide deck and they flash through their slides and you sort of nod and you think you understand everything. But then when you actually go to do the work, you realize, oh, I don't really know how to clean this data or how to fetch this data from SQL. So what we really emphasize is the kind of practical things that you do day to day on your job. And that's one of the reasons why we have to partner with DigitalOcean to be able to bring that kind of live coding interaction to students. So next slide. All right, okay. So one of the place where this sort of really shows is our collaboration with WorldQuant. So WorldQuant University is the largest accredited free university in the world. It's funded by this hedge fund, WorldQuant, which is based out of the New York area, but it has a very global reach. And so they have a mission, the university, to teach and educate people all around the world for free and give them an accredited degree. And they've done this, they started doing this in sort of quant and the quantitative finance world. And then they moved over to the data science world, where they said, we also want to do this here. And they chose us to be their content and delivery partner. So we built a series of custom data modules for them targeted at the developing world, students from sub-Saharan Africa, the Indian subcontinent, Latin America, really focus on kind of the fundamentals and the core of data science. And that program has really grown and taken off. We have over 20,000 students from over 35 countries. And when we started developing this course and building it with them, that kind of gave us a chance to step back and think about, well, what's the core value proposition? What are we really delivering for our students that they can't get anywhere else? Next slide. And when we broke it down, it came down to these 3 things. So they're knowledge, access, and assessment. So what do we mean by that? Well, with knowledge, it's really this idea that data science is the marriage of math and computer science. And we don't just need you to know how to do one or the other. We need you to be able to do both together. So it's hard enough to find someone who just knows how to do math really well and really understands it. It's also really hard to find someone who really knows how to do computer science really well. But what we need to do is find people who can not only do those things individually well, but combine them. And that teaching people that is actually the really big challenge for data science. The second thing is access. So we only teach open source tools because we want you to be able to take our courses and then go off and do these tools or apply these tools and this knowledge that you've learned without having to pay some licensing fee to some sort of large company. But while those tools are great from a being free perspective, they often have a really steep learning curve, and they're difficult to set up and configure. So that's where we come in. We really help companies, we really help our students figure out how to get a lot of that initial setup and configuration done for them so that they can jump right into learning. And what we've seen time and time again is that actually, that setup and configuration really provides a kind of a obstacle that deters a lot of students from even beginning this process and beginning the journey of learning data science. And then finally, assessment. So we believe very strongly, and the employers that we work with who hire our fellows believe very strongly, that data science isn't a practitioner sport. It is a practitioner sport. It's not a spectator sport. You can't just sit around and think about data science. You got to actually do it. So we provide this very hands-on curriculum with lots of code that you can play with, that you can write right there in the textbook, so to speak, our virtual textbook, and it gives you dynamic and real-time feedback so that you know how you're doing. So let's dive into each of these in turn. Next slide. So the first item is knowledge, and I think when you look at how a lot of content is presented in the web around data science, it's often this kind of static format. There's some text, maybe there's some equations, and then there's some lines of code. And sometimes those lines of code are even just a picture of somebody's IDE. So it's not like you can even copy and paste that code into your text editor and run it. You actually have to retype it out all again. And that's not so great. So what we do is we actually built a series of Jupyter notebooks that provide dynamic lectures that have live code. So obviously we have to have our requisite share of text and equations, but we also have cells where we have live code. So that's code that you can edit, modify, and run. And I wish I sort of had a Jupyter notebook here for you, but it's sort of pictures like this, where you run the cells and then we do the plot, and the plots show up below. And that kind of dynamic interaction is really what drives our curriculum, and it's really what drives a day in our courses to engage students and to get them to really bring the material to life and get them to really kind of get excited about data science. Next. So the second topic is really around access, and this kind of goes back to a story that I have, an experience I have, where I went to a training. This was a number of years ago, and it was by one of the leading. I think it was a Kubernetes training. It was one of the leading experts in Kubernetes. The guy is one of the major contributors, and you know, we begin this training and we spend the first half a day installing software. That's it. No, we didn't build any networks. We didn't do any actual learning about Kubernetes. We just sort of sat there and did pip installs and sudo apt-gets for the first half a day. And then sort of throughout the course, somebody would always raise their hand and say, "Oh, that didn't work for me." And the instructor would have to come in and take a look and say like, "Oh, okay, sorry, you're on OS 10. You have to do it this way. Sorry, I forgot to tell you this. Oh, sorry, your version of Ubuntu is actually a little old. So why don't you update this package and try again?" And so it was very fragmented. And the reason it was very fragmented is because everyone was doing this on their own computer. Everyone has a slightly different build. And so you can't have one set of instructions for how to get the software you need set up on your computers. Now, this is compounded in data science because when you're learning data science, you literally have hundreds of packages that you need to download and install. You have to make sure they all work together nicely. And that's actually kind of a big challenge to get these hundreds of packages to work well on dozens and dozens and dozens of systems. So what we said was, okay, forget that. We're not going to solve this problem. We're just going to give you a cloud server. So we control the server. We know it's just some fixed version of Ubuntu. We can load all the tools on, and then it's guaranteed to work. And in fact, we run it in CI testing with our curriculum so that we know every cell will be able to execute when you run it. So there isn't this embarrassing moment when we say like, and here we're going to train a neural network, run. And you say, I just got a timeout error. What's happening here? Right? We don't have any of that. And that's why we rely on DigitalOcean to provide these pre-provisioned cloud servers. Next. Finally, assessment is a big part of it. When you take a class, you want to know that you're actually understanding and comprehending the materials. Your employer wants to know that you're actually learning this stuff and not just zoning out. Your future employer wants to know that you've actually passed the material and know it. So how do we provide this assessment? Well, most online platforms, basically, are doing multiple choice, right? It's like what you did for the SAT. Fill out a Scantron bubble sheet. Okay, well, so it's a web form, but it's basically the same thing. What we realize is that because we have a Jupyter Notebook, we can make assessments dynamic. So it's not just A, B, C, D. It's write a function that does this particular web crawling job, and then submit the answer as a JSON blob, and we'll look at the answer. And these can be very complex JSON blobs, right? You could have many fields and attributes that we're trying to get you to parse out, for example, from some web scraping exercise, or you need to do some sort of prediction on machine learning. So there's a lot there that you have to provide back as answers. And then and the answer is not just yes, you got it right, no, you got it wrong. It's actually a score that kind of assesses how close you got. So that might be how strong your prediction is. That might be how close you are in some sort of string parsing exercise. But the idea is that we realize that data science isn't just about black and white. It's often about gray. And we're able to put that sort of nuance in our submission and in our assessment process.
Yeah,
Now,
I was going to say,
yeah, go ahead.
I think I have a 50-50 chance of getting the ones on the left side right. And I know about as much about data science as I do about rocket ships. So being someone familiar with coding and exams for coding, the right side obviously looks great.
Well, thank you so much, Darian. And with all that, I want to hand it off to my colleague, Rob, who's been waiting so patiently. He'll talk a little bit about our tech infrastructure.
Thanks, Michael. So I want to give you a brief overview of how we accomplish all of these wonderful things about dynamic materials, easy access, and assessment. And this is not going to dive in depth. I'm not going to expect you to be able to reproduce what we do based on this next 20 minutes of talk. Instead, I just want to introduce you to a couple of the ideas that we're using and try to reduce the scariness factor of some of these big terms that you see floating around. So as Michael noted, we're using Jupyter Notebooks. I'm going to tell you how to use a process called JupyterHub, which allows us to easily provision different Jupyter servers for each student. Then we'll talk about running JupyterHub on top of a Kubernetes cluster, which is going to introduce things like Docker and Kubernetes and Helm and all sorts of other scary sounding things. So we'll talk about those, and then we'll talk about, well, now that you have this structure, where are you going to host it? Spoiler alert, DigitalOcean. And a couple of thoughts about how you then make this scale, because we've had classes with thousands of students in it. And it's not as bad as you might think it is. So to start off, just a little bit about Jupyter. As Michael said, Jupyter Notebooks are a wonderful tool for teaching because they allow you to combine code and text and equations and graphics and even interactive elements into a single document. We have a screenshot here, but that isn't even as great because you can't see if you go drag that slider back and forth, things change on the screen right for you. So I won't belabor the point, but Jupyter Notebooks are great for teaching. They're great for programming in general. So if you haven't used them, I recommend checking them out. And when we teach, we make sure that our students get the same set of notebooks that the lecturer gets. And this means that the students need the same environment and therefore the same set of packages that the lecturer gets. As Michael pointed out, it can be difficult to set up this on your own machine. And in fact, we do have students, especially in the World Prompt program, who do not have their own machine. They're taking this course from an internet cafe or borrowing someone else's machine. So we need to provide each user with a server that's provisioned, ready to go, tested, so that they can jump right into programming and not doing all of that other administration work. And the tool we use this is called JupyterHub. So JupyterHub, as the name suggests, acts as a hub between the user and a bunch of Jupyter servers. So it's a little diagram of what's going on here. The user will interact through the web with the JupyterHub server. The JupyterHub server talks to an authenticator, which says, do I know this person? Should I let this person in? Once someone is authenticated, then JupyterHub will redirect them to their own Jupyter server. Or if their Jupyter server is not running, we'll use something called a spawner to create a new Jupyter server, which will be ready to go in just a few minutes, depending on how you do this. Now, both the authenticator and the spawner are things that you can configure. And I won't go into the details, but let's give a brief overview of what options you have. For the authenticator, this is a thing that controls access to the JupyterHub. You have a bunch of options, everything from local systems, just make a local system account for that person, all sorts of OAuth choices, GitHub or Google. There's this LTI that a lot of EdTech people are using, that's built in as well. Some other options, but for the most part, these were a little more complicated than we wanted, because we're teaching in a bunch of different environments and we can't ensure that somebody has a GitHub account or a Google account. And we may not even know who they are until they show up in class on the day of. So we built our own authenticator. It's called the hash authenticator that just generates random passwords for users. And we could just hand these out on slips of paper at the very beginning of class. It's open source. You can find it on our GitHub if you'd like to use this as well. The second big part of this is how we're going to create servers, how we're going to launch individual Jupyter servers. And once again, through this option of the spawner, you have a bunch of different choices. So you can make a local user. So again, one big machine with a bunch of users on it. That's the Unix way. You could do that within a Docker container if you'd rather isolate people that way. Or you can SSH into a remote machine for each user. Or there's a couple of different ways where you can spawn these servers on a big computation cluster. And that last one is the one we took because we do need to scale up to thousands of people. And even if you can handle 10 people on a single big droplet, let's say, there's no droplet big enough to handle those 1,000 users. So we're going to take this last approach using Kubernetes to build a cluster that we can spawn these users on. So let's give a little bit of definition because I've already introduced a bunch of words here. So Kubernetes, what is this thing? It is a container orchestration service. And that definition may not have actually helped you out at much. So first of all, what is a container? Well, this will make experts mad at me, but you can think of a container like a lightweight virtual machine. There's all sorts of reasons why that's a bad explanation, but for our purposes, think of it as a little contained operating system that's isolated from the rest of the system. And one of the big directions in DevOps recently is containerizing services so that each service can have its own set of requirements and can live independently of other services. So quite often you'll have a lot of servers that you want to run together. That's what Kubernetes does. It organizes these things. It keeps track of what's running, what's not, makes sure things start up if they fail, and does all of this work for you. This is very useful for us because we have a bunch of services, if you want to think of it that way, the individual Jupyter servers that we need to have running on a cluster. It's not a perfect fit. We'll talk a little bit about why later, but it's a pretty good fit and it does a lot of the legwork you need to get it running. But there's still a fair amount of things you have to configure. You have to get those container images, those Docker images. You need to have an overall organization to make this run. And this is done, in our case, with something called a Helm chart. And the good news is that all of this is provided by a wonderful project called Zero to JupyterHub with Kubernetes. It's designed by the people who are developing JupyterHub itself. A lot of people from Cal Berkeley, from Cal Poly as well, and contributors from all over the world. It's a wonderful project. Absolutely check them out. And this provides a lot of these tools that you need to set up a Kubernetes cluster with JupyterHub. But you can tell by the number of things I've introduced that we are once again running into the fundamental theorem of software engineering. That is, we can solve any problem by introducing an extra level of indirection. And I appreciate the fact that this quote came to us via 2 other people. So let me back up a little bit and try to give you the bird's eye view of what this ends up looking like when we deploy. So this is our sketch of what's going on. And those innermost boxes, the things that are the Jupyter servers or the JupyterHub, or the proxy, which is the thing that's going to be routing requests to the right component. All these are individual servers that are implemented as individual Docker containers. Now, these Docker containers are running inside of a Kubernetes pod, which is an abstraction that Kubernetes provides to keep track of these sorts of services. You can have multiple containers within one pod, but for the most part, the way JupyterHub works is there's one container per pod. Now, these pods are being run on nodes. So this is actually representing the underlying hardware. So a node is a machine, or in our case on DigitalOcean, a DigitalOcean droplet. And Kubernetes takes care of figuring out where can this pod run, which machine has space, which machine has CPU time, in order to make sure that that pod can do the job it needs to do. And all of these nodes live with inside a Kubernetes cluster. They're watched over by the control plane, which is keeping track of all of this stuff. And Kubernetes is smart enough that it can actually cause the cluster to enlarge or to shrink depending on the usage. And this is going to be very important for us as we try to scale to those thousands and thousands of users. So configuring all this, as you could probably imagine, is a bit of a mess. There are many different components that Kubernetes knows about. I'll give you some of the names here. Honestly, I don't even understand what all of them are myself. You could go in and you could configure every single component with its own YAML file, but this is going to be an absolute pain. So I mentioned before, there's this thing called a Helm chart. And basically, this is a big zip file, probably a gzip tar file, or one of these constructors with a bunch of YAML files in it describing all of these configurations. And it has to have all that information in it. Luckily, we didn't have to write this. Again, the Zero to JupyterHub project came through for us. They provide a chart file that shows us how to deploy JupyterHub. So instead of writing, and I counted this up, almost 5,000 lines of configuration within the chart file, we have a configuration file that just modifies a couple of those things in the chart file, and it's less than 200 lines. And of course, we've written a script to write that file because we can have another level of indirection that way.
Yeah, this is something I wanted to touch on because a lot of people, when they first hear about Kubernetes or they first see what a Kubernetes deployment looks like, it is understandably terrifying, right? Like you get you get your hands into it and you're like, I don't know what this means. I had an indentation in the wrong place. And it's important to realize that just like all the other new technologies, there's been an ecosystem that's developed around Kubernetes, which has created all of these pre-configured charts and designs and infrastructure plans. So it doesn't have to be that you have to learn Kubernetes from scratch to get started in Kubernetes. So just keep that in mind. Thanks so much for that, Robert. That's really interesting.
Absolutely not. When we were first putting together our JupyterHub deploy on Kubernetes, Michael was helping, I was working on this, former colleague Zach Glassman was working on this, and none of us really had expertise in Kubernetes before, but the community is so great out there, there's so many resources that we figured it out eventually.
Yeah, exactly.
Okay, so we have all this configuration, we have all of these tools. Where are we going to actually run this? When we started off, we were creating our own Kubernetes cluster on a bunch of DigitalOcean droplets, and you don't want to do this. It is a pain. You have to configure things, you have to troubleshoot things. At the time, this is basically what you had to do anywhere. But DigitalOcean and a number of other cloud servers are now providing managed Kubernetes clusters. So you just sign up, you start a cluster, they create that master node that governs everything, that takes care of all those issues of connecting volumes for persistent data storage. And on DigitalOcean, at least, you even get a nice Kubernetes dashboard for GUI directly from your DigitalOcean console, where you can log in and see what's going on and see why things are broken for you. The good news is, just because you set it up on DigitalOcean doesn't mean you're being locked in. DigitalOcean is CNCF certified, and I forget what that stands for, but what it means is that the same configuration that works here works on all compatible, all certified managed Kubernetes offerings. So we have run the same configuration on Amazon's Elastic Kubernetes service and on Google's Kubernetes engine. Same configuration. The only thing that's different is the command you run to start up the server or start up the cluster and then to authenticate with it later on.
Yeah, and CNCF, just to help you out there, Robert, is Cloud Native Compute Foundation, and that is the organization that that manages Kubernetes. They're the maintainers of Kubernetes now. So, and that's one of the things that we try to focus on here at DO is not doing that vendor lock-in thing. We want you to be able to migrate both into and out of our cloud as it best fits your business, because we want you to succeed in the end.
This has been very useful because occasionally we get a client who tells us, no, these services have to run on AWS. I don't claim to understand why they tell us that, but it's very easy for us to go set up it on AWS and we could say, sure, we can do that for you. So given this easiness of migrating, why do we stick with DigitalOcean for the most part? Well, Darian will tell you all about the wonderful tech and the good pricing and all of these things. But for my money, probably the best thing that I appreciate from DigitalOcean is the support that we get from very knowledgeable technicians. And I think I can best demonstrate this by talking about a specific thing. This was just a couple of months ago. We were having an issue with our cluster of persistent volumes. We're not attaching to the right nodes. This is a problem because someone starts up their Jupyter server and they don't get all the work that is stored from their previous work on this persistent volume. So I opened a support ticket and we had 22 messages in 8 days. This wasn't just, check here to let me know that you're alive. Each of these was giving me useful information. And the last message, well, not the last one, but the one that really broke it open, I've actually put up here because I was so impressed with it. You don't have to read all the details, but there's 4 things in here. First, the tech went and read through our custom configuration with my permission to figure out exactly what it was we were doing. This is not something that DigitalOcean provides. This is our own configuration that the tech read through, and they found that we were missing a configuration value. Not that we had the wrong value in, but we were missing something. They provided the documentation for that and then told us what they thought we would be able to do to fix that. Turns out it worked just fine. And the happy ending to this story is that we were able then to submit this fix upstream to the Zero to JupyterHub project. So now that you won't encounter the same problem if you're running JupyterHub on DigitalOcean.
And that's such a cool story. We always love to help contribute to open source. It's one of our big objectives here. One of our key company values is our community is bigger than just us, and we try to constantly put more knowledge and solutions out into the ether. So really glad that was a successful experience for you, Robert.
Absolutely. So I think I have a couple more minutes. So I'll just say a little bit about how we scale to handle thousands of users. As mentioned before, Kubernetes clusters, including DigitalOcean clusters, support auto scaling, where the cluster can notice I'm running out of space, I'm going to add some more nodes, or perhaps I have nodes that are not doing anything, I can contract those in. And Kubernetes is actually very intelligent about this, but unfortunately, it's intelligent about this in a way that we can't really utilize. Kubernetes likes to assume stateless services. That is, you can shut something down and just start it up on another node and it will be fine. And for something like a web server, that's perfectly fine. But for a Jupyter environment where you have a Python interpreter running, there's a lot of state being stored there. So essentially, Jupyter and JupyterHub have to opt out of a lot of that nice scaling and rebalancing tech that Kubernetes provides. So instead, we have to put in our own little options to allow Kubernetes to do a good job at these things. So one of them is we have to turn off pods that aren't being used. It's a little bit arbitrary, but we tend to pick about an hour time frame. If you haven't been interacting with your machine in an hour, we assume that you've wandered away from your computer and we can shut it down. But just shutting down the unused pods isn't quite enough because a single running pod would keep a node up. And because we can't do this rebalancing stuff, Kubernetes can't move that pod to another node to handle it. So the best approach we found is to use small nodes. Instead of having a few large nodes that can handle many users, scale things so that you have many small nodes, each of which handles a single user. And that way, as soon as that user leaves, if you don't have somebody else taking that spot right away, you can shut down that node. This does mean that you want nodes to start up and quickly, which means your Docker images need to be small. This is a perennial struggle for us. We're not where we want to be, but for some of our intro classes, we can get a startup in 1 to 3 minutes. Bigger classes where we need to provide larger Docker images with more packages, we're at 5 to 10 minutes. We want to try to bring that down, but that is a continuing struggle. The last thing I will talk about is a little bit about security. I won't claim to be a security expert, but if you do talk to a security expert, the first thing they tell you is make sure your users cannot get shell inside of your Kubernetes cluster. And we go give them a Jupyter server, which gives them shell inside of our Kubernetes cluster. And your initial thought is, well, this is like a VM, so that is a security layer, but no. Kubernetes and Docker are not security layers. You can break out of them. So be careful of that. We address this mainly by ensuring that our Kubernetes clusters running JupyterHub are not shared with other services. We sort of isolate it that way. We have not had anyone break out of their Docker container as far as we know, but even if they do, they're not getting to other systems that we are running. It's isolated in that way. There's a relatively new feature, role-based access controls. This is the security layer of Kubernetes. We are starting to apply some of these things, and that's what you should be looking at to maintain security in these sorts of systems. And I think that's all I have, so I'll turn it over to Darian to tell you a little bit more about the details of the systems that we're using.
Thanks so much, Rob. And I do want to say, as I think Cynthia mentioned in the chat here, if you guys have questions, we're going to have 15 minutes at the end where we're going to answer whatever questions we've accumulated. So please keep them coming, and we'd love to talk about that at the end here. I just wanted to talk about a couple of things that that DigitalOcean does to try and keep the Data Incubator successful. The first, as Rob mentioned, was success and support. Our support team is available 24/7, 365, and they are excellent. As you saw, if an issue is more technically complex than they can initially handle, they will continue to dig their teeth into it until they solve the problem, whether or not it's something to do with our systems a lot of the time. And then we provide solution engineering. That's where I come in. So, I mean, obviously, as you see, Michael and Robert have pretty much figured out how to do this in a really interesting and scalable way. But if they did have questions, and when they do have questions about how to scale, best practices, recommendations, new technologies that they may not be familiar with, they reach out to my team, and we talk them through all of their questions and make sure that they have all the confidence that they need to move forward with their new initiatives. And then finally, account management. The Data Incubator has a dedicated account manager here at DigitalOcean that they can talk to at any time to solve any issue, and that account manager works with our support team, with our solution engineering team, with our accounting team, all of our teams to ensure that the Data Incubator can get the answers that they need in one place instead of having to reach around to a bunch of different people, reach out to a bunch of different people and ask them those questions. So that's one of the things that we do for our business customers that to try and keep them successful. There are a lot of products that the Data Incubator uses today, but because they're mostly in Kubernetes, and this is one of the things I wanted to talk about, the fact that they're mostly in Kubernetes means that, yes, there is some complexity to starting it up, but the management of the infrastructure itself more or less takes care of itself, right? Unless they have an issue or they're scaling or they're standing up a new instance, Kubernetes manages that on a day-to-day basis, so they don't have to constantly scale up and scale things down. The services they do make use of, things like cloud firewalls, right? Obviously, you want to have a firewall around your infrastructure. You can do that on a node-by-node basis, but it's much simpler to simply set up a cloud firewall that protects all of your Kubernetes cluster behind one set of rules. Additionally, they're using CPU optimized droplets. DigitalOcean offers both a basic droplet plan and then a set of optimized droplets. So we have memory optimized, CPU optimized, storage optimized, and the big difference with those is twofold. One, the resource balance is different. Obviously, a CPU optimized droplet is going to have a higher balance towards CPUs than something like RAM or storage, whereas a storage optimized droplet will have much more storage and faster storage. But the basic droplets, while you do get the same resources, they are shared CPU cores, so you can occasionally get bad neighbor effects. To avoid that, on their Kubernetes clusters, Data Incubator has gone for CPU optimized droplets. And then finally, managed load balancers. This is something that a lot of people take for granted in the way that in managing their infrastructure, especially with Kubernetes. But having a managed load balancer that ties into our tag system so that you can automatically place new droplets behind load balancers, things like that, super helpful. So I would definitely recommend, if you haven't checked out DigitalOcean's managed load balancers, that you do so whenever you get the chance. This is kind of a very, very basic DOified version of some of the slides that they were showing you up above. This is the type of thing that we work with the Data Incubator on to produce these sorts of materials, so that later on down the road, if different people are working on it, they can still refer back to some of the stuff we've worked on before. And then finally, Rob talked about the fact that we have great support, and I think that is a huge point of success for us. But really, we are also one of the most value-based, valuable cloud providers out there. We had Cloud Spectator run a series of tests comparing us to other providers, and you can see the results here. These are all with similar resource levels. Per dollar, the performance you get on DigitalOcean is unparalleled. So I'd encourage everybody else to run their own testing. There are a lot of applications out there, especially on GitHub, that will run tests against multiple clouds, and you can see for yourself. And this is a quote that I loved from Rob. Just the fact that you don't have to compromise is wonderful. You don't have to back off of anything that you want to do. You can take the reins with Kubernetes especially, and really make the application that you dreamed of. And we're really happy that the Data Incubator has been successful with that on DO. Here are a couple of other customers who've had similar success. Ryan Bentley over at 1336 Studios said, the control panel allows us to resize our cluster very quickly and painlessly, and abstracting away not only the management, but the configuration of Kubernetes to DigitalOcean has saved us countless man hours. And that's huge. Just the management plane at Kubernetes, not having to worry about that is a big win for a lot of companies. Super Lucky said, we adopted DigitalOcean's managed Kubernetes to deploy one of our analytics systems. We chose DigitalOcean because of developer-friendly dashboards, clear pricing schema, and excellent documentation. These things made it possible for Super Lucky to create a Kubernetes cluster, stateful deployments, load balancers, and services in a matter of days instead of weeks. And that's really the end goal for me, is to reduce the friction between you and between the customer and getting stood up and getting their idea running. And then Gramify said, since we started using DigitalOcean Kubernetes, we need not spend nearly as much time on IT administration, and even developers can control our infrastructure. And another great story with that, Matthias and I have talked about that, and he's super happy with Kubernetes, and just again, the time savings. You can see in all of these, they're talking about how much time and effort it saves to have a managed Kubernetes provider like this. Great. So that's all the sales speak that I wanted to get through. So thanks for bearing with me, everybody, on that. But I wanted to take some time for the rest of this presentation here to go through some answers or some questions from the audience here. Let's see. First, we have a question from Yiju Park, sorry. It's, do students get assignments in Jupyter notebooks? If so, how do you distribute them to each user pod, and how is grading handled?
Both of those are good questions. What we have is we have a very large curriculum. I don't know if you remember the number of pages we figured out when you printed it out, Michael, but I think it was 400 or something like this.
It's very large.
And we don't want to distribute all that curriculum to every student because, well, not every student needs that, and not every student is paying for all of that.
Makes sense.
So instead of having an image with all that material on it, during the startup process of a user's pod, the first time it runs, it goes and it downloads the material it is supposed to get. So that ensures when a machine starts up, the first time they get all that material fresh, but then that's stored in that persistent storage that exists within the Kubernetes cluster. So when they shut their pod down and they come back later and start it up again, they get that same persistent storage. They don't have to download it again. And any changes they've made, notes, experiments, anything they've tried, that stays with them. So they're not starting fresh each time. So that ensures that everybody gets the same material to start with, but everybody can do their own modification and own exploration with that. As for the grading system, it's done within Jupyter Notebooks. There are special mini project, we call them, notebooks. And we just have a little HTTP web service that takes answers that are submitted in a particular JSON form and grades them and sends the reply back. So that's actually running within the Kubernetes cluster as well, just another service within the cluster. And then we have a little bit of code that runs in that notebook that means all they have to do is run a cell to do that submission process. Darian, you're being very quiet.
Yeah, I was a little muted there, my bad. A little muted, I don't know what that means. Thanks for that, that was great. Yeah, that is really interesting and something I hadn't considered. So good question from Yuju Park. Another question from Yuju Park. What kind of customizations did you guys do on JupyterHub? Were there any challenges in your customization process? Did you have to customize it at all?
We did a little bit. So one of the things we did was designing our own authenticator. This was that hash authenticator, which gives people just short passwords very quickly. And this whole thing is maybe 200 lines of Python. It's not a big project, and it was relatively straightforward to implement. Other than that, we do some basic customizations, putting our logo in places, having a little splash page when you first log in that tells you about what we are and how to use this thing. But the JupyterHub project is actually very helpful here. And when we've needed to add some customization that they didn't support, they've actually accepted our PRs to allow that sort of customization to help out. So I can't really say enough about the JupyterHub project. A great group of people who are trying to make useful products for us to use.
Yeah, they're really, really, really wonderful, and we try to contribute back in any ways we can with our, woefully inadequate software. But it's really a great community, and I'm really excited that we've been able to be a part of this journey for Project Jupyter.
Awesome. We have another question from one of the attendees. Is there a reason why it's difficult to find either of you on LinkedIn? I assume they're talking about both of you, but I'm not positive.
I have managed to avoid LinkedIn myself so far, so I'm nearly impossible to find there.
Oh, that would be hard to find
you?
I'm on LinkedIn. I think it's under my username is under my Chinese name, so it's TIANHUILI is my name. I guess I can put it onto the. If you just search for like Michael Lee Data Incubator, I think you'll find me.
Yeah, Google
I have
does
a lot of
good job with that.
Followers.
Yeah, like we said, Michael is popular. He does a lot of speaking engagements and writing stuff, and writing for publications. So it should be easy to track him down. Great. So I got another question here from Leon. Is there a free DigitalOcean tier? And that's a great question. There isn't one right now, but upcoming soon, DigitalOcean is launching its app platform. And that will actually come with, I believe it's a max of 5 free static sites with that. So you can absolutely, you still have to, I believe, add confirmed payment information, but once you've done that, you can stand up to 5 free static sites on the app platform when that launches. So keep an eye out. We'll be releasing more public communications about that soon here.
Maybe we should point out there that I think the cheapest droplet is $5 a month. stuff like that. So that's a cup of coffee a month. And that's prorated too, right? So if you use it for an hour a month, you pay 1/whatever of that that fraction. So
yeah, and there are a lot of affiliates that DigitalOcean works with who provide referral links, and you can use one of those referral links and get a free $25 of credit. And like Rob said, that's 5 months of free hosting with the smallest droplet size. And the great thing about DigitalOcean's pricing is it's so simple and reliable that you know that if you get a $5 droplet, it's going to cost $25 over 5 months and not a cent more, unless you're doing crazy bandwidth stuff. So that's great. Thanks for pointing that out, Rob. We got another question. It is, what are the downsides of using Kubernetes for something like this? What are some struggles you guys have had?
Well, many. The biggest one at the beginning was trying to run our own Kubernetes cluster,
Yes.
because that takes a lot more detailed knowledge about what's going on. And the fact that there are managed services out there just makes our lives so much better. I think the main problem I've had, and Michael, you can say if this is the same with you or not, is just the number of layers going on. That you have a Docker container that's running inside of a Kubernetes cluster that's being managed by Helm, which is provided by Zero to JupyterHub. So when something goes wrong, it's not obvious which layer to look at.
Yeah, I agree with that. The other thing I always get really annoyed by is the number of lines of configuration that Kubernetes is, and so it's a lot of copy and paste and hope you got the tabs right, and
yeah,
I do wish there was I mean, I guess Helm sort of attempts to sort of solve some of these problems, like templating it and saying like, all right, there's like 500 lines of code here. You only ever edit 4 of them, so let's just let you edit 4 of them. But yeah, I don't know. I wish it was like that Kubernetes handled that a little better.
Yeah, and I think that's one of those abstraction layers that just needs time to develop, right? And that's what we're seeing with Helm and all these other tools that sit on top of Kubernetes. Is everybody working with Kubernetes is developing better ways to work with Kubernetes. So I anticipate that stuff is going to be mostly solved problems in the next few years. So I'm excited for that.
Yeah.
And one of the things go ahead, Rob.
I was just going to say, unfortunately, this is the trade-off between the two problems. We can add these additional layers to reduce the amount of configuration, but then when it breaks, it becomes even harder to find the correct layer to negotiate with.
Yeah,
but this is, I think, a unsolvable problem. Just because Kubernetes is so flexible, you need all of this configuration there. So we can complain about it all we want, but I don't think it is solvable. It's something you have to manage.
Yeah, and that may very well be the case. I think one of the things that I always hear people lament about Kubernetes is how difficult it is to work with stateful data. Obviously, you guys have had some challenges with that and have solved it in some pretty clever ways, as you talked about earlier, but that's certainly one thing that I hear people reach for the sky in the rain and scream, why Kubernetes do you do stateful data this way? But obviously because of the advantages it has in other ways.
Absolutely, yeah.
Another question here is, would it be would it be a good idea to set up a managed Kubernetes cluster or create my own? What would be your advice for a beginner? And that's a great question. If you want to learn Kubernetes, you're going to learn more about it probably setting up your own cluster, but man, that takes a lot of learning very quickly. It's baptism by fire if you're trying to get anything that you want to get live. So I would say definitely start out with all of the abstraction you can, right? Start out with a managed cluster with a Helm chart, see if you can get that running, then tweak the Helm chart, right? Tweak your configurations and say, oh, what does this do? See what that changes. That's the way I learned Kubernetes is just taking work that other people had done and breaking it. And I think that's the way a lot of us nerds learn these types of things. So that'd definitely be my recommendation.
Yeah. I mean, just like the modern tech stack has so many layers of abstraction that you really don't want to spend your time learning more. So I really recommend relying on whatever can be managed for you, because for most applications, it's the application that's the sort of driver of business value, and whether you run it on your custom Kubernetes or you're or DigitalOcean or Google Cloud, like the end user doesn't see it unless it fails, and the professionally managed ones are less likely to fail because they're managed professionals.
And they're redundant, right? Like that the master node on a managed Kubernetes cluster is configured to automatically come back up if it goes down, right? So different hardware will spin up in the data center and take over as the master node. If you want to do that on your own, you have to configure that on your own, which is not something anybody wants to do.
Yeah.
Thanks for that. So we got a follow. I believe this was a follow up to the app platform question. Leon asked, do the droplets you get with app platform, or do the sites you get with app platform support auto scaling and load balancing? And the answer is that those app platform sites, to be frank, on the back end they're running a Kubernetes infrastructure. So it's not as though you're getting a dedicated droplet when you run up one of those free static sites. You're getting essentially a portion of a Kubernetes cluster that's running your site for you, but they do auto scale. So that's what's great about having it in Kubernetes by natively, is that it is super easy for us to scale up the static sites. So they do auto scale, and as a result, they should be pretty fault tolerant in terms of scaling. How long, another question we have from the audience here is, how long did this take to get set up? What was you guys' journey from kind of first twinkle in Michael's eye to where you are today?
It's a good question. Do you remember when we started? Was it 2017, early 2018, something like that? We first started playing with Kubernetes?
That sounds about right. I mean, it was a bit hairy. Rob mentioned that we started doing it because we were building these courses for lots and lots of students, and there was sort of this business use case, and Kubernetes had just sort of started getting mainstream. So we were at a point where no one was really offering managed Kubernetes yet. So Kubernetes meant spin it up yourself. So that's why we sort of did it ourselves. If it had been available, we would have gladly just used someone else's and saved ourselves a lot of headache. So it was, around that time when no one, like not even AWS or Google Cloud, were offering this, and we were just sort of in the wilds of doing it ourselves. I guess you could say it's a good learning experience.
Sounds like it.
I can say that I remember one week, shortly after we got access to the managed Kubernetes on DigitalOcean, my colleague Zach and I were talking and said, yeah, we should devote a week sometime just to checking this thing out and seeing if this is going to be a good solution for us. Then about an hour and a half later, he leaned over to me and said, I got it working. And part of that is Zach's skill. He is a very good colleague. But part of it is just how much easier the managed Kubernetes service is. So once we've had this option, we have never been tempted to go back.
That's great to hear. One question we have is, what do you do to scale large classes? I guess when you're having a class that's coming online and it's a lot of people, what do you do there?
So the good news about these auto scaling clusters is don't have to do too much. One thing we'll do is we'll make sure that the cluster will be able to get large enough on DigitalOcean. I think most platforms, you set an upper limit just to avoid creating 2 million nodes in your cluster by accident. But we need to make sure that there's going to be enough space for all of these people. So when you do it as we do with one node per user, the math is pretty easy. I can even do it to make sure that we'll be able to handle it. As for what else we need to do, technically nothing. It would work just to have these people come in and have the cluster scale up. The problem is that little bit of slowness. As I said, it can take 10 minutes perhaps for a new node to be ready to download the image and start serving somebody. And if you had 100 people show up all at the same time, the people who did not get lucky and find open spots will be waiting a little while. So in terms of teaching, what we'll often do 15 minutes, 20 minutes before the class starts is we'll go through and restart all of those nodes if we're doing it as sort of a synchronous teaching experience. just to make sure that when the students show up, the nodes are running, ready to go for them, and they don't have to wait for that.
Of course.
The largest classes we teach are asynchronous, so we can just rely on the fact that students are showing up at somewhat random times, and therefore not much you have to do. The auto scaling just handles it.
That's awesome. Yeah, that's the big advantage of Kubernetes. That's great to hear.
Yeah.
I just want to say one more time, thanks so much, Michael and Rob, for taking the time today. This has been a blast talking with you both. I wanted to mention this has been a huge period of change for a lot of organizations. We've had a lot of customers that have been reaching out asking, how do I, change the way I'm doing things to fit a post-COVID world and a work from home world. So if you have questions about your use case or your applications, how you can migrate it to the cloud or improve the way you're working on the cloud or move to Kubernetes like we talked about today, please do use that link, do.co/contact us. That'll give us a message and we can set up some time to chat. You can see what some other customers are building on DO. If you look at our solutions pages on the DigitalOcean.com website, it's got a lot of customer testimonials and other discussions about how they've done things and the way and what they've been doing. Really interesting stuff. Thanks so much, everybody who attended. This has been fantastic. Please do get in touch with us. Follow us on LinkedIn and Twitter, and we'd love to hear from you. With that, any last thoughts from Michael and Rob? Do you guys want to say your goodbyes?
Yeah.
Goodbye, everyone. It was great being here, Darian, and we're very excited to be working with DigitalOcean and working with you.
Yeah, thanks for having us.
Yeah, thanks so much. We look forward to seeing everybody in the audience in our next Tech Talk, and I'll talk to you, Michael and Rob, later offline, but this has been great. Everybody have a great day.